Good day! In this video, we are going to learn a useful method that can help you to draw a graph based on the different degrees of vertices. For example, here's the numbers of degrees of vertices. We have 3, 2, 2, 1, and 3. Each of the number represents the number of degrees of each vertex. Now, we are going to determine if the graph can be drawn. From the given formula, the sum of degrees of a graph is twice the number of edges. We realize that a graph can be drawn if and only if the sum of numbers of degrees of vertices is an even number, twice the number of edges. Sum of degrees for A. Let's add up all the numbers of degrees of vertices. 3 plus 2 plus 2 plus 1 plus 3. That is 11. Not an even number. The graph cannot be drawn because the sum of degree is odd. For B, the sum of degrees is 2 plus 1 plus 1 plus 3 plus 3 plus 2 equals to 12. 12 is an even number. Therefore, the graph can be drawn because the sum of degrees is even. Now we try to draw a simple graph with the given degrees of vertices 2, 3, 2, 3, and 4. We have 5 vertices here, vertex 1, vertex 2, vertex 3, vertex 4, and vertex 5. Label the vertices with alphabet A, B, C, D, and E. Means that the degree of vertex A is 2, the degree of vertex B is 3, the degree of vertex C is 2, the degree of vertex D is 3, and the degrees of vertex E is 4. Now, mark down the vertices A, B, C, D, and E. How we connect the vertices with each other? First of all, we consider the vertex with the highest degree, vertex E. The degrees of vertex E is 4, means that there are 4 edges coming out from vertex E. If we draw a line joining the vertex E to vertex A, then the number of degrees of vertex A is reduced by 1. If we draw a line joining the vertex E to vertex B, the number of degrees of vertex B is also reduced by 1. Same to the vertex C and vertex D. Vertex E to vertex C minus 1 from its degree. Vertex E to vertex D minus 1 from its degree too. The degrees of vertex E is 4, means that there are 4 edges coming up from vertex E, 1, 2, 3, and 4. In other words, each vertex of A, B, C, and D has been deleted by 1 degree. 2 minus 1 is 1, 3 minus 1 is 2, 2 minus 1 is 1, and 3 minus 1 is 2. We continue to the vertices A, B, C, and D. We have 2 degrees in vertex B and vertex D, 1 degree in vertex A and vertex C. It's easy to make the connection within the 4 vertices with lessest degree. If we make a line joining vertex B to vertex D, they left only 1 degree. Draw the line joining the vertex B to vertex D. Then we can connect the vertex B to either vertex A or vertex C. Try to connect vertex B to vertex A, left only vertex D and vertex C. Join a line between them, vertex D to vertex C. Let's check whether the graph drawn satisfies the given information. The degree of vertex A is 2, 2 edges coming out from vertex A. The degree of vertex B is 3, 3 edges coming out from vertex B. The degree of vertex C is 2, 2 edges coming out from vertex C. The degree of vertex D is 3, 3 edges coming out from vertex D. The degree of vertex E is 4, 4 edges coming out from vertex E. The graph drawn is satisfied to all the degrees of vertices given. Draw a graph with loops and multiple edges with the given degrees of vertices 2, 2, 4, 6, 6. These are the degrees of vertices. We have 5 vertices here, 1, 2, 3, 4, and 5. Label with the alphabet A, B, C, D, and E. Means that the degree of vertex A is 2, the degrees of vertex B is 2, the degree of vertex C is 4, the degrees of vertex T is 6 and the degree of vertex E is 6. Mark down the vertices A, B, C, D, and E. How we connect the vertices with loops and multiple edges? We still consider the vertices with the highest degree, vertex T and vertex E. Both consist degrees of 6. Since the degrees of vertex T and vertex E are higher than the other vertices by 2, loops or multiple edges may appear on vertex T and vertex E. If loops appear on vertex T and vertex E, we know that each loop consists of 2 degrees. Therefore, the number of degrees of vertex T and vertex E are reduced by 2. The remaining numbers of degrees of vertices are 2, 2, 4, 4, and 4. Now, the vertices with the highest degrees are vertex C, vertex T, and vertex E, both of them with degrees of 4, higher than the vertex A and vertex P by 2. Assume that multiple edges appear in between vertex C and vertex T. The number of degrees of vertex C and vertex T are reduced by 2. Multiple edges appear in between vertex T and vertex E. The number of degrees of vertex T and vertex E are reduced by 2, 2. The remaining numbers of degrees of vertices are 2, 2, 2, 0, and 2. Now, we can join in the vertices with ease due to the less degree of vertices. Join the line within the vertex as long as it satisfies the condition of numbers of degrees. The line joining vertex A to vertex E and vertex A to vertex C, the line joining vertex P to vertex C, and vertex P to vertex E. Let's check whether the graph drawn satisfies the given information. The degree of vertex A is 2, 2 edges coming out from vertex A. The degree of vertex P is 2, 2 edges coming out from vertex P. The degree of vertex C is 4, 4 edges coming out from vertex C. The degree of vertex D is 6, 6 edges coming out from vertex D. The loops add 2 to the degree, 2, 3, 4, 5, and 6. The degree of vertex E is 6, 6 edges coming up from vertex E. The loops with 2 degrees, 3, 4, 5, and 6. The graph drawn is satisfied to all the degrees of vertices given. That's all. Thanks and see you.